Thank you, everybody, and I'm very pleased to be here. So this presentation, in fact, I'm making it on behalf of the Engineers Association, Jordan Engineers Association. In fact, we're trying to think outside the box. Now, these are the outlines of the presentation, but let us, start with the concept of changes and challenges. There is a statement here: the measure of intelligence is the ability to change. Without the ability to change, we will get nowhere. So this is an important concept. Do I need this one? No. Yeah, so we ask ourselves, what is the role of engineering education? Why do we have engineering education? Are we intending to develop scientists, theorizers, operators, or what? In fact, for the profession, for the industry, where our graduates are supposed to work, they are looking at us that we should produce people who will become very soon professionals. So the intention of engineering education is to concentrate on the profession. We will have mathematicians, we have physicists, we have biologists to do the scientific research related to the different aspects. So, unfortunately, none of our universities concentrating on developing professionals. They are producing theorizers. They have a good, to a certain extent, analytical skills. But they have no idea about the profession. What are the requirements for the profession? So it becomes an important and very demanding that we have to change our engineering education. Change it totally. No longer what we are doing is acceptable. This is the curve of the development of engineering education. Before the 50s, it used to be based on the practice. We have a good practitioners before the 50s, and since the 50s, the engineering education be dominated by scientists. So we have more mathematicians, more physicists, more chemists, and so on. So the curve is moving towards science until the 80s. So we became more scientists, we learned mathematics, and physics more than the physicists, and very little related to the profession itself. So we want to change this image. We want to move it up again. So we combined the science aspect and the professional aspect together in this. Again, we noticed that previously it's unique discipline. It's not holistic approach. And also we want detailed disciplinary analysis. And at the same time, we have a holistic multidisciplinary approach. So we want to combine those. So we expect that the curve after it goes down to the 90s and started to grow up after the 90s. So we have to ask ourselves, what are the characteristics, what are the professional engineers, in fact, what they do? In fact, professional engineers are the ones who are attained and continuously enhances technical communication, human relations, knowledge, skills, and attitudes. So this is the core of the professional engineers. Also, professional engineers contribute to the effectively to the society. They know the theory, they know how to conceive the different aspects, they know how to design, they know how to implement, and they know how to test and how to operate and to provide services after sales. Those are the functions of the engineers. Unfortunately, the industry in general, they are not happy with our graduates. When they look at the attributes of our graduates, there is a lot of criticism. And they think that if these two wheels, one is the industry, one is the profession, and one is the education, they think that these two together should be linked together in some way or another. So we start to talk about the role of engineering colleges, so that they have to link these two dimensions together, the education and the profession. So we have to know the content, the context of engineering profession in order to change the content of the engineering education. We want to know the content of the engineering profession so that we can change the engineering education. So we have to ask, as engineering colleges, they have to ask 3 questions. The first of all, what is the professional role and the practical context of the profession and the professionals? We need to know what's inside the profession so that we can introduce some changes. The second thing, what knowledge, skills, attitudes should the student possess when they graduate to meet the requirements of the profession and the professionals? The third question, how to make sure that when the students graduate from the university, they attain all these skills and competencies needed by the profession. So we start to talk about the context of the profession. In fact, the word context means it has 2 different aspects: the surrounding, the environment, and the content. So these are the issues that we should take into consideration when we think about the profession. In the last 50 years, there are certain aspects of the profession hasn't changed. Like, this is from 50 years till now, no changes in this, that they focus on the problems of the customers and the society. Those are the professional society. Delivery of new products. For them is the multidisciplinary action. They are talking about the need to work effectively and so on. These are things which it has improved, but hasn't changed. However, there is a new dimensions to the profession. Nowadays, they start talking about sustainability, how to educate our students, what is the meaning of sustainability. They talk about globalization. No longer that I'm going to graduate a student, from the University of Jordan or from Jordan for any university just to work in Erbil. This is no longer acceptable. So they have to think about international dimension. Talk about innovation. Unfortunately, nothing in our curriculum at the universities in Jordan and in the region to a certain extent talking about innovation and talking about entrepreneurship. So they are concentrating circuits 1, circuits 2, circuits 3, circuits 4, and so on, communications 1, so they are very traditional. They don't talk about developments in these things. And also, the economy has changed. Nowadays, the economy is a knowledge-based economy. The iPhone, the income of the iPhone company from one product, it's more than the income from one of the oil countries. This is a knowledge economy. You develop a software package, and the income from that package, it's more than the whole mineral resources of a country. So we talk about also the demographies. In a country like Jordan, it's a small country, and we have 170,000 engineers. So there is an issue related to demographics that we have to take into consideration. Technologically change. Do we accommodate all these technological changes in our programs and in our environment, and also the exponentiating of technologies? The technology 5 years ago is different than the technology today. Our students more adequate with the technology than we, as instructors and educators. And nowadays, you cannot graduate an engineer without having a concept related to business plans and the issues of mobility. These are new dimensions related to engineering education and based on the requirements of the engineering professions. This is a statement from Gordon. Gordon is the person who is the COO of the Analogic Corporation. This company has developed the analog to digital converter. You can imagine the impact of the analog to digital converters on all disciplines in engineering. Has it changed the whole world? This has changed the whole world. All the medical applications based on this. Control applications based on this. Many industrial applications based on this. What he is saying that, what he is saying that he is not happy with the graduates from the universities. They have poor economic return from the investment on engineers. They have limited formal training, inadequate training, inadequate understanding, and also they are not, the personal risk, they are not ready to take risks, those graduates. Again, so Boeing is one of the leading companies worldwide that participated in the development of engineering education. They have made a test for the graduates from different American universities. They gave them a simple design problem. All of them failed, from top universities and from the low universities. All of them failed. So they reached to the conclusion that they cannot continue like this. They need to change. So they start to think about how the, how the context of engineering education should change. It should focus on the customers, innovation, entrepreneurship, customer service, adopting new technologies, innovation, entrepreneurships, and also they have to think about the strategies of the business plans and so on. So they think that profession should drive education rather than education drive the profession. So this is, what they think about this. So they start, some universities, they start to talk about the graduate attributes that feed to the industry. They talk about professional behaviors. Unfortunately, none of our universities, they have the environment, the business plans, the activities designed to develop the professional activities. Planning and organization skills, entrepreneurial skills, all these are the required graduate attributes might contribute to the graduates so that they can become as a professional engineers. This is a report, and I recommend it for everybody to read this report. This is developed by University of Michigan at Ann Arbor about the horizontal integration and vertical integration. At the end of the day, we want to develop products, systems, services, a global knowledge-driven economy. So this is the role of engineers. This is the exact role of engineering education, to guide everything, all the activities, so that we can, at the end of the day, we will be part of the global knowledge economy and to develop services and products. This is the system approach that we see it at different industries. This is what they call it, the V shape. Look at the concept here. This is the system engineering process. To which extent our programs imitate this? Unfortunately, none of the engineering programs, not just only in the region, but in many parts of the world, they are not accommodating this shape. They talk about concept of operation, requirement and architecture, detailed design, integration, system orientation, and all these aspects should be the core of the engineering education, rather than emphasizing 4 courses in mathematics and the student, he doesn't know why he is taking partial differential equation. Okay, so we are theorizers in our program. So we need to go to achieve this shape. These are a number of reports. They said that engineers should be able to conceive, and we will explain what is meaning of conceiving. They start to move, they should move towards design, not just only to stand at the edge of design. They have to move from the design to the implementation, and from the implementation to the operation, and from the operation to testing and services. So these are the different aspects should be the basis for engineering education. These are some reports, word reports. Talk about engineering, educating engineers, and this is, you know, the basis so that they can be professionals. This is a very famous report from the Engineering Academy of the United States. Talk about engineers for 2020, emphasizing the professional dimension. Engineering for 2020 is the same thing. Again, we will have this is in European. Again, the other one, a HELLO project. A HELLO project developed by the European Union with the OECD. OECD, they developed, this is a good report, good aspects that we hope that everybody will look at their outcomes of this a HELLO report. Again, this is from the UNESCO when they developed the higher education for the 21st century. They talk about the different aspects related to the profession and so on. These are also another reports. Even, you know, the tuning report, this is a great report, also, you know, done by as an outcome of the Bologna process. They developed this tuning report, and they talk about the Bologna process. All these emphasized the aspects of the profession. We don't want to keep our students to stay as theorizers as they are today. Again, the UNESCO developed this important report, the learning the treasure within. And they say there is 5 pillars. We learn to know, we learn to do, we learn to live together, and we learn to be, and we learn to transform. These are the 5 pillars of learning. Unfortunately, none of our programs been designed on those 5 pillars. I think we have to rethink the engineering education in particular and the other aspects of higher education in general. This is the situation. We have to change. To change what? We have to change our mission. When I asked this morning who is doing the program objectives, I mean it. It's a country level. It's not just only a dean of engineering or a head of department will put those objectives. It should be agreed by all the stakeholders, because the outcomes of the process will not serve the dean, will serve the country. So the country should have a say on the objectives of the program. Again, we talk about the content. We have to change the content. We have to change the purpose. We have to change the physical environment. Physical environment currently at the schools of engineering are not conducive, not producing any good professional engineer. Oh, God. Can I ask the organizer to extend it a little bit, please? Yeah. 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 Anyway, we have to change the culture. This is important. Again, this instructor, this is the old type of instructor. He is talking about innovation, independent innovation, and then telling them critical thinkers who will do exactly as I say. This is nonsense. This is a typical situation at our university. So we have to cancel it. We have to remove it from our dictionary. We have to change it. So we have to move as the student is the center of everything. All of us are there to enhance the learning process of our students. So we have to move from teaching to learning, from research to innovation, and from services to shared leadership. Again, to all my colleagues, I have a message to convey to every one of them. If you don't change, you will be changed. If you don't change, you will be changed. And you will change by what? Nowadays, there is a big threat to all engineering schools. There is something new called corporate universities. For example, I'll give you a simple example. If I am Cisco certified, and another colleague, he got a bachelor in computer science, and you have a job, which one you employ? Yes, you employ the Cisco certified. So this means because he got the knowledge and the know-how. You are not going to. So what's happening? And this is happening today in Jordan. For example, if you Dar al-Hikmah, Adwiyat al-Hikmah, what they have? Nowadays they have a college. Dar Adwiyat al-Hikmah, they have their own college. So they graduate their own staff. So what will happen that most of the big companies, BMW, Pfizer, Mercedes, McDonald's, they have their own universities. So they graduate, and they are not worried about accreditation. They are not worried about the titles. They graduate the graduates that they need for their work. So nowadays there is around 800 to 1,000 corporate universities. Last month I was doing a presentation in Dalian in China, Inosoft University in China, and the university is surrounded by 100 companies. And all of them, they participate in that university. So you can see now the huge changes in the system. The change, what we are proposing.
By the way, I saw you have WhatsApp.
Okay, good, great, thank you. Thank you. Now the change that we are proposing today is to move to the concept of the CDIO. CDIO is an abbreviation for conceive, design, implement, and operate. This is the new trend in engineering education. What do we mean by that? What happened, in particular in the United States, they were not satisfied with the quality of the graduates. So they asked for forming a committee, national committee from the industry, from the university, from the government. They call it I agree. And this committee, at the end of the 90s, beginning of the 2000s, they encourage schools to meet the real world needs and rethink their education strategies. This is in the United States that we consider that this is the best in the world. This is what's happening there. So ABIT listed their expectations for graduate engineers, industry, university, government. So this is the participants. Those are the list of the participants in that meeting. And we can see that some top universities, MIT, Washington State University, Virginia Polytechnic, they were in that meeting. And also the professional society. Among them, the ABIT in that meeting. And they came up with the concept that they are encouraging universities, they have to reshape their education to meet. As an outcome of that meeting, ABIT introduced their criteria 2000. As an outcome of that one. And then they move it. Nowadays they have the criteria 2012, and recently they have 2016, I think. All these as outcomes from those meetings, because they have realized that if they don't change, as I said, they will be changed. Again, find some educators. They said that we will take a lead in introducing changes, and this happened at the MIT. They start to introduce the concept of the CDIO so that they can make the curve to go up again, and they introduce the concept of the CDIO. So those are the issues related to the professional, the context of the professions, starting from customer service to business plan, working effectively, innovation. They consider it as an input to the CDIO process. So all the issues related to the profession consider the input to the CDIO process. Again, this is, so the CDIO process, conceive means that we have to educate our students about the customer needs. We have to educate them about the technology. We have to educate them about the enterprise strategy, regulations, technical and business plans. These are it's a process before the thinking of design. So we are preparing them so that it becomes part of their personality, these aspects. Then they have to go to the design. Sketches, drawings, different aspects. limitations of the design, then they have to move from the design concept. Some universities, they talk about the design, but we are moving one step further. We have to go to the implementation. Still, when we do the design, we are a bit theorizers. We want to move from the concept of the design to the concept of the implementation. And after building the prototype, we have to operate that. So these are the 4 different phases of the CDIO process. Now, these are the verbs, the terms, when we talk about conceive. What does it mean? Conceive, they have to accept, to assume, to believe, to practice, to realize, to appreciate. All these are activities related to the conceiving process of our students. And also, these are the different operations. We talk about in the conceiving, we have two areas. This is the mission, how to enhance our understanding of engineering, and then we start to develop conceptual design concept. Then we move to the preliminary design, detailed design, element creation, system integration, life cycle support, and also the evaluation. So these are what's happening in the industry. If you go to any industry, they move through all these processes. This is what we would like our schools of engineering to move into, rather than give them 3 courses in thermodynamics, and at the end of the day, they have no idea how the engine is working, and how to maintain an engine, or how to operate an engine, or how to design an engine. So the CDIO, the different people, they put a mission. They put a vision. They want a curriculum to be developed to take into consideration all the aspects of the profession. And also, they want this curriculum, when we want to implement it, to be based on the experiential learning. This is a new terminology. We should adopt experiential learning. So they have to have the experience, and from the experience, they have to learn. And also, the important thing of engineering education is the workspace. No longer is the classroom is enough. No longer is the lab is enough. So we have to expand that, what we call it the workspace, and we should have a robust assessment. Still, the concept of first exam, second exam, and the final, this is the obsolete. No longer acceptable. We have to move to a different assessment process. So, So the core of the CDIO, I have to transform the culture, to change the culture at the institution level and at the program level. We have to have deep working knowledge. Working knowledge. This is important. Working knowledge. It's not any type of knowledge. We have to creation and operation. So we start to give problems, project-based learning, problem-based learning, and then simple projects, complicated projects, real projects, and all. And we have to understand the impact of research. None of our faculty members talking to our students about research and the impact of the research on the programs. So here in many countries in the world, nowadays there is students that don't like to go to engineering. Why they don't want? Because they don't know what are the different aspects. They don't understand what the responsibilities of engineering. So we have to move from current to the desired. Still, this is supported by the basic knowledge. What happened that this initiative started by the MIT. MIT is one of the leading institutions worldwide, and with the 3 universities from Sweden. So they developed this, and it becomes, as they start to change the culture. And in fact, in the MIT, it's the aerospace engineering who developed the concept. So this is the timeline, how the concept developed. From 97, now it started with those 4 universities. Today, in 2019, we have 178 different universities worldwide are members of the CDIO initiative. And this is the distribution of the universities who are subscribing who are members of the CDIO initiative. Unfortunately, if we look at this area, we have just only 2 institutions from this area. One from our neighbors, and the other one is the Australian College of Kuwait. I worked very hard to bring this concept to this university. So we have just only, you can see that how it is in the United States, how it is in Europe, in South Asia, and in Australia. Unfortunately, none of Arab universities is thinking about it. There is one institution in Tunisia. Yeah, you can see it, there is one in Tunisia. So I think we have to rethink what we are doing. What happened that the owners of the initiative, the ones who developed the initiatives, they put a set of standards, what we call them the CDIO standards. The CDIO standards, based on the best practices related to the engineering education and the profession, not just only the education and the profession. I know that, okay. These are the set of the standards. They have 12 standards. Those standards, first of all, the standard number 1 is related to the context of engineering education. The standard 2, 3, 4, and 5 is related to the curriculum. Related to the curriculum, so they talk about the syllabus. And by the way, the syllabus, the CDIO syllabus is around 20 pages. The syllabus of CDIO, I distributed number of I have limited copies. So there are around 20 pages, the syllabus of the CDIO. Anyway, and then they talk about integrated curriculum. Not each component of the curriculum is living in an isolated island. It's integrated. So you can say the output from one course to input, and then you have multiple systems, multiple inputs, multiple outputs from the integrated curriculum. And design, build experience. When we talk about introduction to engineering, unfortunately, we talk about the different types of engineering, but we never inform what is expected from the engineer when he graduated. And unfortunately, most of the professional institutions in the country, companies, industries, they don't have it. They don't have a program for new engineers, for new graduates. Anyway, standards number 7 and 8 related to the integrated learning experience and active learning, and then standards 9 and 10 talk about the staff. You cannot develop this without working on a staff, and they have the issues related to the enhancement of staff teaching skills and enhancement of staff CDIO skills. All these concepts related to design, to implementation, and so on. And then we have to have a robust assessment method for the skills. Again, we have to evaluate the program at large. I know I have taken, this is the structure. This is the structure of the standards. So we have to ask, why CDIO? Okay, why CDIO? And how we are going to implement CDIO. So we have to have, what is the CDIO? We talk about the syllabus. And also, by the way, the syllabus is defined to the 5th level. I will explain what does it mean to define to the, and these all the different activities related to the how to implement the CDIO initiative. This is the first standard. Anyway, but I want to move. Yes, I know. Okay. Yeah, but this is an important slide. Please look at it. This is the strict. This is what we have currently. Here we are here. We are here in this slide. This disciplines going vertically from first year till graduation, and isolated. Now the second one is an integrated curriculum. So there is a vertical disciplines, and there is interweaving projects between the different disciplines, and also this is progressing from one year to another. So we expect that the graduates is familiar with the different disciplines. He can how to integrate all these disciplines, and also to go to the level where at the end level we design, we implement, and we cooperate. The third one is problem-based learning. There is a problem, and the last one is the apprenticeship. He's an electrician. He knows just only that part. So we can see that the importance of the CDIO approach. These are the details of the standards. It's available so that you can go back to all these. Yeah. Now the other thing is the syllabus. This is an important dimension. We talk about the knowledge, the skills, and the attributes, level of proficiency, and we talk about the engineering practice and applied across a variety of programs. There is a four areas. Yeah, these are the 4 different areas related to the syllabus: technical knowledge and reasoning. This is a new term, never been introduced before. And reasoning, as an engineer, you should have the skill of giving reasoning for what you are doing. Personal and professional skills and attributes. Also, this dimension, it's not there in other even accreditation. Entrepreneurial skills, teamwork, and communications, conceive, design, implement, and operate systems. And we will see, for example, this is the way that we develop the programs. It's not a head of department sitting in his office writing the program, and then after writing the program, they start to develop the learning outcomes, and after the learning outcomes, the attributes. No, it started completely different. It started from the needs, what the engineer is supposed to do, and then we goals, and then we develop the syllabus. From the syllabus, we start to think about the curriculum, and from the curriculum, then we design the course design, and then we have the different aspects. I don't want to go through these. Yeah. In fact, currently we are here. Partially we are here. We are here in the current systems. But we are linking those with the 4 or 5 pillars of the UNESCO. So when we look at our graduates, either they will become researchers, system designers, device designers, product support engineers, entrepreneurial engineers, or managers. So we have to accommodate for all these types of professions. Now, those are the 4 pillars of the syllabus. First of all, disciplinary knowledge and reasoning. The second one, personal and interpersonal skills and attributes. When you want to go for a work, a new job, initially you see the HR person. You don't see the technical person. If you convince the HR person, then you move to the second step. The third thing is interpersonal skills and teamwork and communications. And then the 4th pillar, which is the conceive, design, implement, and operate. So all these, yeah. So for example, this is the second level. We start from technical knowledge, knowledge of underlying sciences, core fundamental knowledge, advanced fundamental knowledge. Then we go, this is the, within, for example, this is level number 2 related to ethics, equality, and other personability. We start to talk about ethics. And then from the ethics, we start one level lower than that, one's ethical standards and principles. So we have at least 4 levels. 4 levels in the syllabus. What will happen if I understand the syllabus? Immediately I can develop the program. If I understand the syllabus, and this will give me also the learning outcomes and the program attributes, if I understand all these. This is a comparison between CDIO and ABIT. This is ABIT 2010. You can see, look at here, number 3.3, communication in a foreign language. We talk about internationalization. This statement, this part is not part of the ABIT. System thinking. Even the ABET and the other accreditation agencies, they don't talk about system thinking. In this approach, system thinking is a must. And they talk about implementation and operation, very, very slightly touched by other accreditation bodies. This is, with the Canadian. Again, also communication and system thinking is not there. This is with the European, also the cooperation with the European. I think this is with the European. You can see there are certain areas as a part of the CDIO not touched by the Europeans. Not touched by the Europeans. So I believe that, let me just say something, and these are also, all the standards, they have three things. They have definition, they have also rationale, why we are selecting that standard, and also there is a rubric, how to assess that. So these are the three pillars for any standards. But let me say something at the end, so I'll finish in 1 minute. That CDIO is not an accreditation. It's not an accreditation. It's a club. It's an initiative. If you participate in that one, then if I want to build, for example, laboratories for space engineering, I will find 100 universities to help me in doing that. And we have monthly meeting, virtual meeting, about the developments. And we have annual meeting for the region, and we have an annual international conference. So all the members, they will come and they talk about their experiences and they share this. In addition, which is unique, they have what called CDIO Academy for the students. So the students, they compete on their projects on international basis. Every year there is a competition for the students. So the CDIO is an initiative worth it to be looked at. Thank you. I've taken more than was supposed to be. Thank you very much. Thank you.